There's a lot of community members online this evening, and we're going to do our best to manage the time so that everyone has an opportunity to have their questions answered. And so without further ado, I'll introduce Jeff Redwood to begin his presentation.
Ms. Rodden, could you just expand the screen again? It shrank a little bit there. Make it
Yeah,
as big as possible for folks.
is that
There
better?
we go. That's much better. Thanks. Sorry, Mr. Redwood.
Thanks for that intro, Laura. Yeah, good evening, everyone. Try not to take up too much of your time. A lot of people are keen to watch the Jays game. Yeah, as mentioned, geotechnical engineer with Tetra Tech Canada, based in the South Okanagan in the city of Penticton. And this island slope hazard study was originally completed by Shane Green out of our Kelowna office, I believe a couple of years ago. And he has since left Tetra Tech. So I've got myself up to speed on the project and what was done, and we'll be giving this presentation tonight. Can you go to the next slide, please?
It went right to the end.
Yeah, that it was quick.
Okay. There we go.
Yeah. Yeah, so overall, the purpose of the study was to identify and evaluate potential geohazards for the island. And that was accomplished by developing criteria to evaluate potential hazards on the island. And then specifically when it comes to slopes, determine the potential setbacks from the slopes, a safe distance from the slopes for development. So um, yeah, the recommendations in the report um, in a nutshell, includes, if you're going to be building within these setback areas, to engage a qualified professional to assess the property and the project specifically for whatever development is being proposed. At the end of the day, the results of the study and the report are meant to provide information. So the regional districts and any property owners or potential property owners in the future are informed of potential hazards, and they can make informed decisions on how to deal with them. Next slide, please. So here's a list of reference documents for the study. The first three there are previous studies that have been completed. The first one was by another consulting engineering company, Thurber, done in 2003, so quite a while ago. And then Tetra Tech was involved in two additional studies in 2021 and 2022. The first one was on the mainland for the Qathet Regional District, and the second one was for the islands. And both of those studies consisted of typical flood mapping for coastal areas. The other two reference documents there are guidelines from the province regarding coastal flood hazards, how to assess them, terminology, um, and all that kind of stuff, so that there's some sort of consistency. Now, this is a field study that um, it deals with the environment, it deals with climate, it deals with materials that were created by nature. So um, not everything fits in a perfect box and can be classified that way. So that's the purpose of guidelines, just to try and bring all professionals closer together in terms of what they'd be delivering and how to deliver it. So those two documents were quite useful, and there are many, in geotechnical engineering and similar disciplines, always using those types of guidelines. Next slide, please. Yeah, so one of those reference documents for CDIC guidelines, really it's those ones are recommend, a recommended guideline for designing dikes to protect areas that are potential to flooding. And all the design recommendations or standards given in that in that guideline, as for most guidelines are, at a conceptual stage. It's high level. It's not going to get into the specifics because that's the specifics are meant for consultants or others to get involved on a project specific, but also location specific basis. So it gives it's a conceptual to start, and then as a starting point, and then it goes from there for each project. Next slide, please. Yeah, so the flood hazard area land use management guideline. Again, that one is fairly high level. However, it's useful for local governments and people that would be, reviewing development plans and providing and approving plans. So it gives them a bit of a guideline, again, to try and keep everyone on the same page as much as possible. And with that one actually has a projection for sea level rise in BC, which is quite useful because as sea level it has been constantly changing since the last ice age, and it will continue to change. And any kind of coastal area that is a challenge. A change of sea level plus, if there's any kind of climate change, it just resets the bar constantly. So that guideline, that detail in that guideline is very useful for these types of studies. Next slide, please. So just a quick overview of the Thurber study from 2003. They did something similar to what Tetra Tech did. They established hazard setback lines for safe building locations. They used 50-year and 200-year horizons, so trying to predict things 50 years and 200 years from now. So they found some very similar things that we did with their study in terms of erosion rates, especially on the north and south shores. This island is orientated east-west, and the north and south shores have the greatest width to, say, storms that are approaching them. At the bottom there, just highlighted a key point from that study, and that the Savary Island continued to be reduced in width from south to north by natural erosion forces, soil erosion, including landslide activity, is a constraint to residential development along the South Island Bluffs. If global warming causes a significant rise in sea level, which is what over 20 years later we are seeing, that erosion rates will almost certainly rise from those in the past. The idea of that is things are constantly changing. This is erosion. of landforms and creation of new landforms is just a typical process all over the world. Anyone that's lived out in Northern Ontario, if you've seen what the shield looks like there, those used to be mountains. So erosion is significant. It takes mountains down and deposits them somewhere else. Next slide, please. So for the 2021 and 2022 studies that Tetra Tech did, it's consisted of orthophoto review over from 2006 to 2017. So about 11 years there. And the conclusions from that, saw erosion rates between 0 meters and 0.4 meters per year, which in these numbers correlated well with the Savary study that was done in 2003. There is also geological mapping of the shorelines for the different material types and developed an erosion potential ranking system that was used in the current slope hazard study for the island. So these phase 2 of that was for the islands. Yeah, same thing, the geological mapping, similar scope there. And that report there also used the water levels, typical water levels in the region, and other variables from the guidelines from the Ministry of Environment for their change adapting guidelines for coastal flood hazard land use. And that was relatively recent. That's 2011. Next slide, please. But here's just a table of the typical superficial geology material types of the island. The ones that are high are marine and aeolian. Aeolian deposits are windblown, typically sand, maybe fine and silt deposits. So you think of sand dunes, those things are constantly moving. When you think of deserts, so sand dunes are changing and they're literally moving every day. So not a surprise there that the erosion potential for the types of landforms would be high. In at the opposite end of the spectrum, for comparison, is bedrock. I think that's intuitive to everyone. Bedrock is quite hard, and it takes quite a while to erode. And if you're looking on shorelines or even along riverbeds, wherever there's bedrock outcropping, that's typically where the soil or material above it has stayed in place where other things around have eroded away. Next slide, please. So this is out of the report. It's the erosion ranking system, has multiple variables here. So the type of shoreline, the geology of the back beach of the shore, the slope angle of that location as well. So the back beach, things that are a greater slope angle, a higher degree of erosion rate compared to something that's relatively flat. Vegetation plays a big factor in erosion. Anything that's heavily vegetated typically will not be eroded. For something that has zero vegetation, the soil would be eroded quite a bit easier with just typical processes like rainfall. And then when you start adding in storms and wave runup, that would erode it at even greater rates. And there's some field observation modifiers. So there's a few things there. if there was anything visual in the field for slope instability, such as say, tension cracks at the crest of a slope, overhanging areas, so steep slopes with overhangs. If there was areas where, say, there was an erosion right at the toe, and the material was highly erodible, and then there was evidence of erosion there, that would, for tall slopes, that would come into play as well. Oh, next slide, please. So here's just the ranking system. So what was done here is there are numbers taken from the previous table based on what's seen in the field for different areas and geology types. And they're scored accordingly, and then the ranking system just breaks it out from very low to high in terms of erosion potential. So things that are very in the very low category have a low potential for erosion, such as bedrock, shoreline, and things that are high would be something similar like a windblown deposit that doesn't have much protection near the toe. It would be susceptible to erosion from storm events and even just regular wave action and tidal changes. Next slide, please. So I put together an example here of how the ranking system and the charts work. So if there was a shoreline that had gravel and boulders lining it, and then the back beach was say a recent marine deposit, that would be say silt or clay, and a slope angle between 15 and 40 degrees. 15 degrees is not too bad. It comes to slope stability. When it starts to get to a 2-to-1 type of slope, 2 horizontal to 1 vertical, which is about 27 degrees, that and above, typically we see more problems with that. So assuming a vegetation cover of some bushes there, and storm exposure of a lower scale, 1 to 2, only 1 to 2 meters, and then a slope that's less than 20 meters in height, and some visual indicators of instability. Gets total those up, comes to a score of 46. The next slide, please. And that's where 46 would plot on the ranking system. So somewhere in the just squeaks over the moderate. So very close to the high end of low and to the low end of moderate there. So this purpose of this was to give you an example of how it works. Next slide, please. So this is taken from one of the figures from the report, and it identifies the erosion potential, which is uses the red light, yellow, green light. Green is good from erosion potential, which means the erosion potential would be low, and the red would indicate high areas of potential erosion. And though those charts shown before were used to create and map these areas. Next slide, please. I'll quickly go through these different types of slopes that were evaluated. This is what was used to determine the setbacks from the toe. There's so set forward distances from the toe and set back distances from the crest. It's based on the slope height and the slope angle. Primarily those two variables. And then there would be some setbacks from the toe and the crest, kind of like a factor of safety, right, to account for variability in natural material that's deposited, also climate change and also human activities, which can modify things as well. So the take-home point for this is if you have tall slopes and if they're steep, there is a greater risk of erosion, which would lead to greater setbacks from the toe and the crest. Next slide, please. So the first example is rock slopes. The slope's greater than 30 degrees and a height that's greater than 3 meters. The setback from the crest of, say, a rock slope is only approximately 7.5 meters. And that's just due to the erosional nature of bedrock. It doesn't erode very readily. So, you can, as a high level starting point, a setback of 7.5 meters from there has been deemed to be appropriate as a starting point. And then, as I mentioned at the beginning, to get a professional, qualified professional involved, and they look at the exact location and the project that wants to, potential project. You can, extend or reduce those setbacks based on the project specifics and the location specifics. Next slide, please. Here's just a visual of rocks. There's rocks at the toe of the slope. Up the slope is bedrock that's exposed, and near the crest is also vegetated. So a good example of something that I think intuitively everyone looks at and says, yeah, that's probably not going to erode very quickly. Next slide, please. So then the next case is inland slopes, and similar criteria. It's the slope height and the slope angle that really governs the setbacks here, and the setbacks from the top of the crest of the slope and from the bottom. We're talking about inland slopes now, so nothing on the coast. When slopes fail, if you have infrastructure on the top and the bottom, either can be impacted. If it's too close to the crest, it may compromise the foundations of the building, and if it's too close to the toe and the slope fails, the material that flows down the slope can impact infrastructure. So whether it's a house or a pipeline or power lines, setback distances from the toe and the crest are quite common for inland slopes. Next slide, please. So this is an example of inland slope. I drive past this every day and look at it. As someone that deals with slope stability on a daily basis, it's always interesting to look at. So you can see where the dashed red line is. All the material below that has failed off that slope and is accumulated at the toe of the slope. It's quite a bit. The accumulated material is actually higher, is greater than half the slope height, which shows this material likes to erode and fail quite often. There is you can see at the layer at the top, there's a distinct line between some darker material and lighter material. The material at the top is quite coarse. It's got boulders and cobbles and gravel in it, and the material underneath of it is finer. So it's fine sand and silt, which is highly erodible. It stands up nice and tall. You can see on the right side of the photo there, that's near vertical slopes, which there are some similar slopes like that at Savary Island. Yeah, we get a good water, a storm event, something that comes over the crest. It'll erode it quite quickly. Next. please. So for coastal slopes, which are unique in the way that there's low tides, high tides, and there's also climate change that is impacting the level of the ocean. So the way this criteria, it took into consideration um, the high the highest high water level tide from the year 2000, and the highest same kind of tide, but what it would look like 100 years in the future. Um, as you can see, as the tide comes up or the water level increases and rises, it encroaches farther into that slope horizontally. So it gets closer to the crest of that slope, towards inland. And this, the change in the water levels was from the 2018 hazard land use management guidelines from the Ministry of Forests, Lands, and Natural Resource Operations and Rural Development. That ministry just keeps, it seems like every time there's a new government, they just keep tacking on another, some more words and more ministries to merge into it. The next slide, please. So for coastal slopes, got three cases: low, moderate, and high erosion potentials. So for the low erosion potential, again using this criteria of slope height and slope angle, but also taking into consideration sea level rise. That's how the setbacks from the crest were determined. So it would be greater than say an inland slope because it does not have that change in water levels over time. And I have an example on the next slide. So this is an example of low erosion potential and some of the criteria that was used to give slopes or shorelines an erosion ranking are used here. So the shoreline is covered in cobbles and boulders, so that's good for preventing erosion, whether it's tidal erosion or sea level rise or storm wave run up. There's also some tree debris, some logs there as well, protecting it. The shoreline behind it is also heavily vegetated. Lots of mature trees there, and by the looks of it, if you want to go in there, there'd be bushwhacking and need a machete as well. So that again improves the erosion strength of the soil there in the land. Another key one here is there are the slopes. The slopes from this photo, they don't appear to be very steep or very tall. So that also improves the erosion potential. So that's low erosion, and we'll move on to the next slide for moderate. Similar criteria. The setbacks are looking at 15 meters, 15 meters or 1.5 times the slope height. So a little bit higher in terms of a setback due to being in the moderate range. So on the next slide is a visual example of that. So the slopes themselves are taller and steeper than the last example for low erosion potential. They're also not as heavily vegetated. We can see, there aren't as many trees. We can see through them. We can see the ground cover. The ground cover is not too bad. It's as shrubs and ferns there in the kind of small to medium category. However, there are areas which there are exposed soil areas there near the crest of the slope, but also near the toe of the slope as well. And that material, just looking at the photo, appears to be, um, like sands, maybe fine to medium sand. It doesn't look bony, so it's just, it doesn't have cobbled boulders in it. So it would be susceptible to more erosion. Next slide, please. So in the high erosion potential category, we're talking about 2 times the slope height for setbacks. So I think that kind of makes sense with something that's higher erosion potential. We want to have a setback that's farther from the crest. And the next slide is a good example of this. So that is an aeolian deposit. People have probably seen this this area. As a somebody who likes geomorphology, this is a pretty cool spot. You can see all the windblown waves in the slope itself, the way it was deposited. If you got up close, they probably looked kind of like waves frozen in time, except it was created with sand. So at the toe of the slope is failed material. That looks like, yeah, sand of different grades, and then there might be some silt in there as well. It's indicates that this slope is eroding. Material is accumulating at the toe, and because this is on a coastal area, the tide looks like it's out right now. But that material, I imagine, would be a lot more if it wasn't because of the tides that have been taking it away. The foreshore there has a couple boulders. That's it. That's not really going to protect the area from erosion very, very well. And when it comes to vegetation, there's not much on there. There's some shrubs and grasses that are clinging to the surface, only because they grow quickly. There are no trees on there because the slope erodes quickly and does not allow trees to establish themselves on it. So it's an indicator of erosion right there. Those slopes are quite tall and they're very steep. The bottom half appears to be near vertical. And on the right side there, outlined in red, is a failure. There's more accumulated material at the toe, and you can see where it's not, the slope itself is not flat across or a level plane. There is a bit of a wedge that is developed in there. So whether that's, typically we would see that from water runoff from above that would be running over the slope, finding a preferential path, and then eroding material as it goes. Next slide, please. So again, back to this, after all of that, this back to this slide that shows the surficial geology, so the material types of that were mapped for the island, whether it was bedrock or aeolian deposits of silt and sand, and other types of material, and then as well the erosion potential marked there in green, yellow, and red along the shoreline of the island. Next slide, please. I thought I'd throw in some examples here of setbacks from slopes. Again, this is from the Okanagan. This is along the highway just north of Penticton. The roadway you see at the bottom of the photo is actually a pullout, so that's not the highway itself. We have in the Okanagan here, we have similar slopes to that previous example of the Aeolian deposit on Savary Island. We have something similar that's highly erodible. They're glacial marine, or not marine, but a glacial lake deposits that consists primarily of silt, which is very fine material, and up to about 10% of fine sand. They're somewhat cemented, which the Aeolian deposit from the last example looked like it was somewhat cemented as well, which would hold it together until water touches it. Water takes it down quite quickly. So these slopes are all over the Okanagan, and a gully is formed here. It's outlined, those dashed outlines there. That would form from water above the slope that's been accumulating in one place, whether that's natural drainage paths or whether they've been affected by development by people. These gullies form. Now, development, if stormwater management is not, if stormwater is not managed well, it will increase these gullies and just eroding land very quickly. It's quite scary how quickly it can erode, and whenever there's a storm event here, I'm always looking around to see what is fallen down, and usually are getting calls. So because these slopes are very tall, as you can see by the scale of the cars and the houses, and they're relatively steep too, at least near the crest. You can see that they're near vertical. Everything below that is failed material that has accumulated, and you can see that there is vegetation that is established on those slopes on this failed material. And as vegetation establishes more and more, it's a good indicator that the slope has found a stable angle. There are two houses up there, indicated by the red arrows. The one on the left is a good example of a house that's probably too close to the crest of that slope. There's been a lot of development out here, as there is all over this province. Without the knowledge that we have today of these types of hazards. And there are lots of things that have been built within these areas, within setback, what we consider setback areas today. The house that's on the right, it is up on a higher slope. However, this setback from that slope is significantly more. It is probably getting close to a good spot, just as a screening level. The kind of criteria similar to what we would use, what has been recommended for Savary Island. A little bit different because we don't have to deal with the coast, coastal erosion processes, and the rain. A lot more rain on the coast than we do here. But yeah, there's a good amount of setback there. And yeah, this is a good example of the difference between maybe not enough setback and one that looks adequate. Next slide, please. So this slide shows potential mitigation measures for coastal slopes or land or anywhere that encounters water. I mean, this could apply to rivers as well. I've seen applications like this used all over the province and in rivers. This is considered a hard structure, and it is hard because it is riprap. It's just blasted bedrock, large pieces of it. On the left there, it looks like it was just piled there to protect the land from erosion, and on the right there, they're interlocked blocks a little bit more yeah, likely, for a nicer look, um, but also maybe people are spending more time over on that spot. Next slide, please. And it shows the same area, just a view more to the right of the house. There's more blocks there. Again, there's some bedrock outcropping on the right side as well, which helps with erosion protection. And it appears that they placed a lot of blocks of rock there just to continue the erosion protection. So that's an example of a hard structure. And now the next slide will illustrate softer techniques for erosion protection for shores. So this location here, there's granular material on the beach itself. The material there looks like it's cobble and gravel and sand. So that's pretty decent material. If one wanted to beef up the erosion protection for this example, using larger material, more cobbles, maybe not something as big as riprap, but something that's more natural that would occur there. Would have less of an impact in changing the hydraulic conditions at that location. The slope there is also relatively gentle, and there are some logs there to absorb energy as well. More things like that could be placed. Natural things could be placed and either anchored or embedded into the ground to hold them as well. So it's kind of more of a natural way to absorb energy. When we start looking at the back for there. There is some vegetation. There is an area where it looks like vegetation is sparse, and there's some erosion potential there. Um, some off the top of my head, some mitigation measures there to prevent erosion or even to allow for reestablishment of some, say, loft land in that area. Would be some geotextiles. Um, the example that I've suggested here are geocells. They are a cellular confinement system, and they're quite useful. They're open-celled cells that are connected together. They're open, which means you can fill them with material. So in this case, material can be placed on that slope to reestablish land, and then on the edge of the slope and the crest, geocells could be placed on it, and then also filled with natural material. The natural material would also helps with reestablishing vegetation. So uh, geocells are nice in that way, where if you get some good vegetation growing on it, you won't even be able to see the geotextile at all. And the next slide is an example of that. Um, so that's what the cellular confinement system looks like. Um, many cells connected together. You can get them in panels and then connect them into any kind of shape or size that you would like. You can see the lower cells here. They look like they've undergone some erosion and the material has been taken out of them. But the ones above still have material, still have some vegetation. So um, I just found that picture on the internet. That's not from a project or anything. But it gives an example of a soft design technique along with the other soft design techniques. Instead of just using one, it's good to use many to try and solve a problem. Next up is questions. If anyone has
Yeah,
some specific
thanks,
questions about the
Jeff.
study.
Thanks, Jeff. This is Julia Dykstra. I'm the planner here with qathet Regional District. I'll just pass it over to Director Lennox just to thank Jeff for his presentation.
I will thank Jeff. Thank you, Ms. Dykstra. Yeah, we appreciate your presentation. I took a couple pages of notes here as you were talking, and but really we want to give as much time to people online here a chance to ask questions. So there's some hands up, but Ms. Dykstra will kind of lead the effort here, and we'll try to answer as many questions and also take stuff away. Thanks.
Thank you, Director Lennox. Thank you. We can use the raise hand function. I see that a couple of participants have already started that, and I have opened up the question and answer chat for you to share any questions that you may have. If somebody asks a question, you are able to also upvote that question so that it can show up on the top of the list if we do get lots of questions. We're going to try and record all of the questions so that we can add them to a frequently asked question document that we're maintaining. So that'll be available online sometime in November, and the recording of this will be posted next week. So the first hand up we had is from Reed Ferber. If you can also try to keep your comments or questions to 2 minutes, that would be great.
Okay, thanks, Julia. Can you hear me okay?
Yes, I can. Thank you.
Excellent. Thank you, Mr. Redwood, for the presentation. I understand that you're not, all right, it's obvious that you're not the author of the report, but I'm hoping you can answer some of these questions. I'm sure you'd agree that the accuracy of your predictive model not only depends on the accuracy of the climate prediction models, but also the accuracy of the hydrogeological model. Has your model, which has been used in several different reports by Tetra Tech, has this been cross-validated using real-world data? That's my first question.
That's a deep dive.
Yep, it's an important dive,
into
though.
the details. And that's so. Yeah, I wasn't the author of this. I wasn't involved until recently to kind of put together a presentation. So. Well, yeah, unfortunately, Shane has left Tetra Tech, and he would be the best person to answer that. To not get bogged
Okay,
down.
let me
in
move
too
on then.
much
If
of
you're
it.
not able to answer that, let me move on.
Yeah.
So I'm a research scientist. I deal in large, disparate data sets using categorical, continuous variables, qualitative, quantitative data, which is essentially what you're dealing with here. Now, what you've done is you've taken categorical variables, or sorry, continuous variables like slope angle and slope height, and you've just arbitrarily turned them into categorical variables. The best example is a slope angle. You're saying here that a slope angle of 39 degrees is 3 times less likely to contribute to erosion than a slope angle of 40 degrees. So 1 degree difference results in a 3-fold change in weighting. And that's not appropriate from a scientific perspective. But so I'll just state that as a fact. But more importantly, there are other resources out there. Like your references didn't really involve any peer-reviewed literature. I'll just talk about one very briefly. I know I'm under the time limit here, probably over the time limit. Chesneau published a peer-reviewed study in 2020 on Savary Island, and reported that we have an initial half width of 330 meters, so 660 meters across. And after 100 years, using your exact same hydrogeological or the same reports that you base your report on, they actually say that there's only going to be a 7.5 meter change in the coastline, in the width of Savary Island. That's 7.5 centimeters a year. You're basing it on Thurber from 2003, who at best has 0.3 meters, a third of a meter. So I have a real problem with the fact that your model has not been cross-validated. Your model inappropriately takes continuous variables, turns them into categorical variables. You have an arbitrary ranking for those variables within this, and it's not based on peer-reviewed science.
Thank you, Reid, for your comments. I'm going to move on. If Rick Thaddeus is ready with his questions. Rick, can you unmute yourself?
Yeah, I'm ready.
Thank you.
I'd just like to speak about one of the positive things that have happened. I've noticed around the South Beach Trail from the top to bottom of the bank, the broom has been displaced by wild cherry without any human assistance. I think human assistance might benefit the spread, and I think it should be considered helping that along. There, willow wattle was planted on Garnet Point. That's been very successful. There are other methods that people that have used around the island, and I'd happily tour you and show them to you, ways of mitigating erosion on Savary. And so I'd just like to say that there's a lot of positive news, and there could be a lot more. And that's what I have to say. And now I can't hear.
Ms. Dykstra, you're muted there. Okay.
Thank you. I was just going to thank Rick for his comments there. That's really nice to hear that wild cherry's coming back to the area there. Jeff, did you have any comments about that?
Yeah, it sounds like vegetation is reestablishing itself. So that's whenever that can happen, that's a positive for erosion protection.
Thank you. Did anyone want to type any questions into the question and answer function? It looks like Reid has raised his hand again. Reid, I'm just going to leave some room for some other people who may want to speak here. And just going to give it a minute here to see.
Julie, I was just going to say that the chat is disabled in my Zoom meeting. So it might be disabled for other people.
Yes, the chat is disabled. There should be a question and answer Q&A pop-out box that people can access from their meeting options. That was closed earlier, but it is open now, and we did have the function working quite smoothly on Tuesday. So if you don't see that, check some of your ... buttons. Those seem to open up quite a bit for people. Otherwise, you can raise your hand up. Oh, thank you, Joanne. Did anybody have any questions? Well, we are looking really good for time tonight. Okay, we've got one here from Heather Manson. Have you considered historical Savary Island data? Over the last 60 plus years, we've observed that the tip of Indian Point waves back and forth, quote unquote. Some decades eroding more on the east side and other decades eroding more on the west side. This is seen in aerial photos. Have you looked into this? So, Jeff.
I believe that was looked at as part of the air photo review. Looking and establishing erosion rates from that way. I believe the server would have. I think they did something similar as well in their study.
Mr.
Julie, yeah, Julie, I can add to that. Several years ago, we did a Green Shores training on Savary Island, and we had John Reedshaw, a well-known coastal engineer, along with the Stewardship Center for BC, deliver the training, and it happened out at qathet at one of the island residents' homes, and we walked the shoreline on the south and north of qathet Point, and discussed that at quite length with a lot of the residents there. So it is known, and it's talked about in the Thurber report as well.
Mr. Redwood, would that be just look? I'm thinking about the mapping that you showed us and sort of the red, orange, green. I think Thotec wasn't red; it was more in the yellow zone. Maybe that's what that's speaking to, is that it doesn't have as high a perceived erosion. Is that correct?
Or in which location?
Thotec, that's on the western point of the island.
Western Point.
I know you don't have the report up anymore here, so.
Western Point. Yeah, it looks like it's green and yellow from our mapping exercise. And that would be based on probably looking at the materials there. So it looks like it's till material and also on the points there, they don't seem to be at the same kind of erosion rate as the middle of that island.
Yeah. Just to echo Ms. Rodden's comments, I participated in one of the Green Shores Level 1 courses. It was kind of mid-island around the dock area and other spots, and there was some big value for me learning about again things that property owners and governments and different people can do to mitigate. I see Mr. Graham's hands up there.
Thank you, Director Lennox. Yeah, we do have a hand up from Bud Graham and a few comments in the question and answer regarding some of Reed's comments. So I just wanted to address that to the group, that there was some points made about scientific studies. And I just want to remind the audience that the regional board and staff practice at the direction of the board a professional reliance model. So Laura and I are not geotech engineers, and we are directed by the board to hire consultants. So I just want to remind everyone in the audience that if they have any challenges or constraints that they want to talk about regarding the specifics of the credibility of the engineers that were involved, that possibly we could do that offline. Whereas this information session is more for people to learn about how slopes can be mitigated, how they can apply to their property, and how it applies for their experience on Savary. So I'm going to just leave it at that for now and move on to Bud Graham. Can I ask you to unmute yourself, please?
Yes, thank you. Can you hear me?
Can hear you.
Okay. Yes, I initiated a significant look at Green Shores initiatives for Indian Point. The log walls we had along the island that were put in were a disaster. They exacerbated the erosion activity on our end of the island, and where natural forces could allow logs to come in and dissipate the energy of the waves. And I believe that Green Shores Initiative is very important, but it requires more than 150 feet of waterfront. It requires a systematic um, program for Indian Point if you're going to try to stabilize Indian Point. And I'm not even sure you will ever stabilize Indian Point, but you can maybe get more of Indian Point protected, because the end of the point may never be protected, but there is a way to deal with this. And I believe Green Shores is the right approach, but it needs support from the regional district, because you cannot get every property owner to agree on the approach to move forward. And I understand that's a very difficult decision, but somehow I think some leadership from the RD would be helpful.
Fair point.
Thanks, Bud. I'm just going into some of the other questions here. We've got Heather saying, please do consider lived experience of people on the island. Truly, it's our experience that the point waves back and forth, erosion rates may vary over time. And there's a few other comments here. Let's see if there's any questions for Jeff. Maybe this question is better answered by Laura. Is it legal for people to make changes to the foreshore as they wish? For example, decide to put some stone-filled gabions in front of my property and just go ahead and do it myself.
Technically, no, that is not legal. You should apply to the province. You go to Front Counter BC. The local office is on Duncan Street in the Ministry of Forests office, and you apply for a permit to do works in the foreshore. And once you do your application, you have to have your proposal of what you're proposing to do. And it is recommended for works in the foreshore that you have a qualified professional advising you, because you don't want to be spending a lot of money on a method that is not going to work for your property. And so, that's why we recommend people have a site level assessment, apply for the permit, and then you move ahead with your shore works.
Thank you, Laura. Rick Thaddeus also typed in a very similar question. Most waterfront properties have Crown land in front of them, and this is a jurisdictional issue, and are property owners allowed to protect their land? I think that you covered that by letting people know that they need to talk with Front Counter BC so they can assess what the proper jurisdictional level is. You can always contact Front Counter BC. They do have a local office here on Duncan Street. So if you can't find that number online, give Laura and I a call, and that is a phone number we have memorized. We've got a question here. Why are there only recommendations for setbacks and none for mitigating erosion?
Mr. Rodden, I don't know if that's a question for you as kind of in a planning sense, or maybe for Mr. Redwood as far as the report.
I can answer, and Jeff can fill in any blanks, but this study that was done is a high level study. And so the findings are predicting lands with potential erosion risk. And the study is recommending that property owners have site level assessments to inform what their actual erosion potential may be. And until a qualified professional assesses what the particulars of the site are, you would need a qualified professional to recommend what mitigation would work on your property. And many property owners on Savary have done this. I spoke with quite a few of them in July when I was there for the community meetings. And they've used numerous different mitigation measures.
Thank you, Laura. I have a question that I can just quickly answer from Ann West. In a world where we are following recommendations for development, what kind of effort would be involved in getting a variance if we feel the risk is not that bad? So I think that, Laura, you can jump in, but in this case, for the Savary Island Official Community Plan, there are no recommendations at this point to regulate any of the setbacks. Therefore, a variance is sort of a moot point. We recommend, if you have your property and you're planning to develop it, that you hire a registered on-site professional to inform your development, and they can provide you the exact nuances for setbacks and soil type and erosion that are specific to your property. And we've got Bud has raised his hand again. I'm just going to read one last question here from Amy, and then we'll go over to Bud with his hand raised. I noticed the example with the high erosion on the slide showed wave action. We are protected here. Even during winter storms, we rarely see waves more than 3 feet. This doesn't seem to have been taken into consideration. Can you please comment on that, Jeff?
Don't know exactly where that location is, but in terms of wave action and what we see today compared to what you see in 100 years, that could vary. It's expected to be different. So, what was taken into consideration was the rise in sea level. That's a big variable there. That changes things. So that's yeah, it's the rise in sea level, and then there's also the rise in intensity and frequency
I'm
of
talking about
storm
the
events.
liability.
Are you muted?
Thank you.
I'm muted right now.
Okay, because
No, you aren't, bud.
you're talking to these other people.
Bud, you are not muted. Did you have a question?
Uh, yes, what I would like to say is when I tried to do a Green Shores initiative on our property at Indian Point, I hired a coastal engineer to do a design for a Green Shores initiative. Unfortunately, our property hadn't eroded from the Crown foreshore on front of our property onto our property, and I had to assume the liability insurance on the Crown property if I was going to do anything there. So I have to wait for it to erode on our property before I can do any protection of our property. I think that's absurd.
That's a follow-up for sure in advocacy with the province. I didn't know about that one. Thanks for that, bud. Just taking some notes on that.
Are you muted?
Yeah.
Ms. Rodden, any comments on that one? That seems to be the fact, is that if you're trying to take action outside your property and then there's other factors.
I am familiar with the site, and there is a Crown right-of-way
No.
between all of the properties there and the water, the high natural watermark. And so it is Crown land. So you need permission, and Mr. Graham was denied permission unless he assumed the liability. So that is correct. Yeah, it's particular to that site. And I can't really say more than that because it's Ministry of Transportation
Okay.
that has
Bud, can you
authority.
mute yourself?
Mute.
Okay, I have to unmute here.
You are unmuted.
Okay. Oh, sorry, I missed. I might have missed the question. Laura,
Bud,
did I miss
Oh.
the what?
No, that's fine. I just added to what you said. I didn't
Oh.
say anything alternative.
Okay,
I would like to.
I was just trying to do something for Indian Point,
Right.
but I couldn't get enough property owners to agree with me that we need to do something consolidated.
Okay.
Because I think the only solution you can have is one consolidated plan
Hmm.
for a large portion of the island, because 150 feet of waterfront
Right.
doesn't fix the problem.
Understood.
thanks, Bud. I will mute Bud. Thanks, Bud.
Julia, I'd like to pick up on a question I see in the chat from Emmer Dubois.
Thank you.
Yeah, so she's asking why we would use the information from the study to inform recommendations or policy. And basically what I want to say there is the reason we're offering this is a learning opportunity. So of course, if you have property on Savary, you walk Savary, you see the shorelines, you see the cliffs, you walk the trails down to the beach, you know it's eroding. But under the Local Government Act, a local government like the Qathet Regional District is obligated to consider natural hazard lands when we're doing long-term land use planning. And an official community plan is a long-term land use plan. We're looking ahead 20, 25 years. And if we want to be supporting sustainable development, we want property owners to be building and using their properties in a way that is going to protect their investment and protect their homes or their cabins over time. So a study like this, while there have been some who have been trying to discredit the findings, this study was done following provincial guidelines, and Tetra Tech Engineering is an engineering firm in good standing with the Association of Professional Engineers and Geoscientists in this province. And they are held accountable under the Professional Governance Act. So like Julia said, it's professional reliance. We contracted Tetra Tech to do the study. It will inform our land use planning. And this is a best practice across the province and around the world, really. This is a best practice in land use planning. You have high-level technical study done, and that will inform your policies and what you recommend to people to develop safely. And that's why it's important, and that's why we think the recommendations are suitable to use for guiding policies.
Thanks, Laura. And to follow up from that, there's a comment in the Q&A that I'd like to read out because I think that it would be good to address it in this webinar. From Jay Moore, there appears to be a disconnect between how the Slope Hazard Study's initial community communications on Savary Facebook, the purpose of this report. There was no apparent indication initially that this report was intended to make development recommendations. The recommendations included have been a source of deep concern among island property owners. Where did the directive to make the development recommendations come from? And why wasn't it more clearly communicated at the earlier stage?
Ms. Rod.
Yes, we have not posted any information to Savary Facebook. We have posted information to the Qathet Regional District Facebook page, to the Qathet Regional District website, and in the Savary Island News. We have submitted information and we have done some mail out. So we never posted anything on Savary Facebook. I don't know what you're referring to. So I can't really respond to that.
Julia, you're muted again. I don't know if it was automatic or on purpose.
My apologies.
Okay.
Thank you, Laura, for clarifying that. We have two hands up. We haven't heard from Bill Duncan yet. Bill, would you like to unmute yourself?
Thank you. Can you hear me?
I can hear you.
Yeah, Ms. Rodden and Ms. Dykstra, I'd like to take you to task for your comments about Reid Ferber's comments on the study. You simply cannot hide behind what you're calling government policies and saying that the report meets all of those. If you find out there are some concerns about it, you have to investigate. The study, if what you are going to do is based on that plan, and if that plan has some problems, or sorry, if the report has some problems, then it's you guys on the line as well. It's not just Tetra Tech. You cannot blindly say that we rely on it because we've done all we have to do because that's what government policy requires. You have heard some legitimate concerns about it. You have to investigate. Thank you.
Ms. Rodden, any comments? I mean, point taken.
Yeah, I'm happy to discuss it offline. I don't think it's appropriate in a public place, and we have the author or a representative from the company online.
unmute myself again.
Yeah.
I've got
Thank
a question here from Lee Davis. Is the regional district going to take any action to mitigate the slope hazard? For example, provide any materials or funding?
Well, Ms. Rodden, I think we have a bunch of takeaways from the report itself and also the discussions that we've had. And, you know, we have limited tools that are at our disposal, but I think that's literally what we want to talk about with the advisory committee and sort of what the future holds, right? So it's a good point. What actions can we take? And that's what I'm about, you know, that are reasonable and everybody wants to get done.
Yes, and what we have heard loud and clear from residents in the engagement process so far is that they are the stewards of the land. And so, you know, I think that it's up to property owners. That's their responsibility. They have made it clear they don't want the regional district to regulate land use. So we can promote people having site level assessments done. We can promote people consider the information, but without regulation, it's up to the individual property owner to decide if they have a problem, if they want to mitigate it or they need to mitigate it, and what they're going to do.
Yeah, thanks for reiterating that, Laura. We still have quite a few comments in the question and answer box related to things like regulation. And I just want to point out to everyone that the phase 3, what we heard report, is available online. And we did hear resoundingly from the Savary Island community that regulation is not the way to go for Savary, and that information and guidelines and talking to people one-on-one about what's specific to their property is the route to go. So people can definitely find that on the Savary Island Project website.
I see another hand up there, Mr. Duncan.
Thank you, Director Lennox. Mr. Duncan, did you have a comment?
What was that from last time, maybe?
No.
Okay, thanks.
Must have been left over from last time. Thank you.
Okay, no problem.
Okay, thank you. So since a lot of the questions are still relating to protecting one's own property and the setbacks that were made as recommendations in the study that were pulled out from some of the deeper look into that study. So I am hoping that everyone's questions were answered here. If anybody does have any pressing question, we do have a few minutes left here, but I'm going to leave some of those slope setback questions to just remind people that the regional district has heard that Savary does not want to regulate the slope setbacks. Yeah, Laura.
Yeah, I'd like to just respond to a comment from Reed Ferber because he's asked if we could respond to his question, and I'm not sure which question it is, but he has a comment about the setbacks. And I think that if you were, you know, listening to Jeff make the presentation, the setbacks identify areas of potential hazard. And if you have a site level assessment done of your property, it may be that the setbacks could be reduced. And until you have a site level assessment done, we can't say for certain that someone can't build somewhere. So I think there's been some misinformation or an interpretation of the study saying that the report is saying no building can happen in those setback areas. And what the study is actually saying, and please, Jeff, correct me if I'm wrong, is that these setback areas are potential hazard areas, and people should be cautious. And the recommendation, the only recommendation is in the study, is that a site level assessment should be done to inform development to ensure it's safe.
Correct. The purpose of the study is really for information. It's to identify potential hazards, and then try and delineate them, trying to figure out, well, where do you draw that line where, you know, you won't be impacted by the hazard, which is always very, very difficult. In the field of engineering and geosciences, geohazard professionals debate this every year. Go to conferences and where we all discuss these types of things. So yeah, the purpose of this is really just to inform people, hey, there's a potential hazard here. If you're going to develop within, you know, this area, recommend that you look into it a bit more with more detail, with the qualified professional to provide advice on, you know, something that's location specific and also project specific. So it's not meant to be a extremely specific. It's high level. It's the extents of the area, which is delineated by setback lines, is it's conservative, so that when someone digs into it a bit deeper, and it's specific to the site and the project that is proposed, those you know, areas of potential concern might not be areas of potential concern. So I deal with this all the time in the Okanagan. As I showed on those slides, those slopes, there's all kinds of issues with those slopes. And right, there's always a starting point, which is what this study is. And then you go from there. You just get more detailed with the assessment when professionals involved and at the specific location, and they know exactly what's going to be occurring there in terms of development.
Thank you. Thank you. We are coming up to time here at 7:30. I just want to respect everyone's time this evening. I've got two more questions here, one from Amy and one from Liz. Amy says, so once you have a site level assessment, are you obligated to follow the recommendations? If so, everyone on a bluff will be too afraid to have an assessment done in case it follows the survey's recommendations. So either Laura or maybe Jeff could answer that as a professional geotech.
Ms. Rodden, maybe you want to take a stab. I think I understand
Yeah.
the question. If you get a recommendation, is it you must, or is it's guidance? Like,
Yeah.
explain.
So I talk to people every day across the region who have bought a property, vacant property, they're going to build a house. If it's on the water, I always recommend a site level assessment to ensure you have a safe setback from the sea to avoid coastal flooding, and that if it's a high bank property, that you have a safe setback from the bluff so that you're not going to be at risk of erosion. And the onus is on the property owner. But what I say to people, because I'm a planner, I'm a professional planner, and I promote sustainable development. I don't want people to be developing homes that are going to be damaged through erosion or natural forces. So, I mean, if it's an area of potential hazard, I'm going to recommend the site level assessment. The onus is on the property owner. And many property owners follow the advice, or they get that same advice from someone they know or family, and they realize, you know, where the actual potential is. They find a safe building site. They can be closer than the standard, whatever it might be, a 30-meter setback. But the onus is on the property owner. You have to satisfy yourself that you feel safe and that you're protecting your investment. And we're not going to get in the middle of that as a local government. We just are promoting sustainable development.
And maybe just to add on to that, in general, I think most people, if you are bored enough to watch our our planning meetings and our board meetings, you can see that the directors that represent the different areas in the region, Area A for me, have heard clearly from people that we appreciate recommendations and guidance, but that again, depending on the topic, they do not want regulation. So that's where we're saying we use specific terms like recommendations versus you must, and that's a bylaw and tools like that. So
Thank you, Director Lennox. We've got one question from Liz. I don't know if this question can be answered in this webinar, but she's asking how many properties are impacted by the potential hazard?
Well,
Mr.
all coastal properties
Okay.
are impacted. And all properties in the current OCP are within those development assessment areas, and site level assessments are recommended. And it's looking like the new OCP is going to follow suit with that, based on the study, based on what we've heard from the community, and to meet our requirements for promoting a development that's resilient and sustainable.
Thank you. So that is time. It's 7:34. I just want to respect people's evenings. Laura, did you want to have any closing remarks?
Yeah, just thank you for joining us and, spending an hour and a half to learn about the study. And Julia and I are here in the office. If you have any questions after this, please, you can email us at planning@qathet.ca. Julia, did you have that slide you used the other night? So you can call or email us. And thank you, Jeff, for sharing your presentation with us.
You're welcome. Hope everyone has a good evening.
Thank you.
So as Julia said, the recording will be on the project Savary Community Plan project website next week. And anyone that missed it this evening is welcome to check it out.
Have a good night, everybody.